First, we will discuss about the behavior pool. In my last video, we have created the behavior definition. Inside the behavior definition, we have defined what needs to be done. We have to create, update, delete, and those kind of things automatically came up when we created the behavior definition. When we tried to execute our application, that time what happened, that we were not able to run our application because we have defined that time the authorization master as an instance, but we didn't do any implementation for that. As I told you in last video also, we only define all the things what needs to do in the behavior definition, but actual implementation we will do in ABAP Behavior Pool, or in short we call ABP. This ABAP Behavior Pool are the classes which is used for the implementation of the behavior definition. We have created this particular class in our example to implement this authorization. Same way, in many scenario, if you have some determinations, features or functions which you want, or numbering which you want to implement and is additionally apart from the standard operation card, then you have to create this particular behavior class and you have to implement your logic. In our case also, we have created this class. But if you saw in my last video, let me open that particular class. So one thing what happened in during this last week, somehow in my trial account, the standard demo examples got errored out. So I was not able to access, somebody got deleted or something happened. So what I did, I created new trial account. I deleted the existing trial account and I created new trial account, and there have implemented each and everything again. But the thing is that you guys used my ZI travel Techem in that particular trial account. So I have used here everywhere instead of Z, Y. So you can see now, if you see here, I have those three tables now in the Y booking Techem. Instead of Z, we have Y, and we have the definition called YI, and the interface view and consumption view YC, and metadata extension also I have created with YC. And we have created behavior definition. Just we replaced Y with G with Y. I backed up my already code and I put those each and everything again. If you want to see my current status of the application, same as my last video only. But if you still want to see, we can go to our service binding and we can preview it out. But it's same. Now we are discussing, I created this particular class. Instead of Z BP travel Techem, I created Y BP travel Techem. And if you open this class, and let me minimize this one now, just we didn't do any changes from my last status of the video, so don't worry, just we change the naming convention. Instead of G, we use Y because the G somebody else already using. So in this case, we have created this particular class, but if you can see this global class, first important thing, does not have any implementation. Always this particular behavior pool class in global level, we will be not having any implementation. We can have some implementation to interact with the outer world, but we don't have usually. Instead of this, all things we will implement in this local types. Not local types, sorry. In this local types, we will be having the two kind of classes. And this global class is always, it's implicitly always abstract and final. What I mean, if even I didn't define here it is abstract and final, it is implicitly SAP declares as a abstract and final only whenever we will define this particular behavior pool classes. So in this case, you can see definition public, abstract, final for this particular behavior of this particular travel entity. And the implementation, whatever we will do in the local types. The same thing I have written here. So first thing, we will do the implementation in the classes, not in the definition. We will do in the behavior definition, and all the implementation we do in the behavior pool. So we call this behavior pool. This is the new thing, ABP. And the global class is always we will not implement anything. So as I told you, in the global class we will not implement, but in the global class we have the local types. We will declare their local handler classes. There we will do our implementation. Again, that there are two kind of handler classes. One is the two kind of local classes. One is the handler class and second is the saver class. The handler class we will use for the during the interaction phase. Whatever we are doing, that all code we will put in the handler class. In the saver class, during the save whatever we are doing, those all the method we will put in the saver classes. So implementation of code in the interaction phase and saver. So this local handler class always start with LHC. We can have multiple handler class based on our requirement. For example, in this case, I will gonna create 3 local handler class for each entity. One more important thing, you can create this particular class, as I told you, at the global level also. But in this case, if you have a smaller application and if you have not number of entities are less, then you can create at the global level. But in this case, we have the different 3 entities, and for each entity we have the different operations. So I will define this particular class at the entity level. So implement in class this particular behavior pool class name, and unique will say that for each operation you will define only one method. That is the meaning of the unique. For each operation you will define only the one method. For example, if you want in many scenario also, if you want to do create, update, delete also, you have to define some method. You will for one method for one operation. So like that we are telling for the unique. So this is all about the behavior pool class. If we talk about again syntax, as I told you, so the normal class, how we define class name and public abstract final, then end class. But here for the behavior class we have some additional syntax for behavior of, and we have to give the behavior definition name here for the behavior classes. So this is the additional syntax, and this class is only useful at the perspective of RAP. You can't create this kind of classes normally, but the RAP we have this additional syntax for behavior of, and you have to give the behavior definition name at the end of it. Is automatically generated, no need to worry, as you can see here as well. If you go to the global class, the for behavior of, you can see here for behavior of, and you have to give this particular behavior definition name here. Okay, and the second thing, this all the behavior classes name should start with BP underscore. In my case, it started with BP underscore. The same way in your case also we have to start, so we can separate the normal classes with the behavior pool classes. So as I told you, these all are the implicitly abstracted file. Even if I don't declare this is abstract or final, it will be all automatically abstract and final. What that mean? We can't instantiate those classes, or so we can't instantiate or inherit as of now. So the real substance of the behavior pool is located in the local type. So real substance means whatever we want to implement, as I told you, all the implementation we have to do in the local classes, not in the global level. And those local classes are the handler class and the saver class. Handler class operation in the interaction phase, where we are interacting with we are creating, deleting, updating, modifying. Once we have done, when we click on save button, that time save class method will be triggered, and that operation within the save sequence, those will be done in the save classes. And during the interaction phase, whatever we are doing, those things we will write in the handler class. So if we go one step deeper in these classes, so suppose we have defined this particular class, behavior class. In our case, this is the class. If you see in the local type of this particular class, we have created local handler class. You can see the naming convention LHC, means it is the local handler class. This class method will be during the interaction phase, whatever we are doing, those implementation we will do in this particular local class. So this will always be inherited from CL ABAP Behavior Handler. In the same way, one more local class is there for the saver that will be inherited from the behavior saver class. So these are the something we have to remember, and in turn these both classes have one super class called CL Behave ABAP Behave. This is the foundation class of the handler and the saver classes, and this class is the handler class, and this class is the base of the handler class. Whatever the local handler class we will create, we have to inherit from this one, and whatever the local saver class we are going to create, that we have to we have to inherit this class in that particular local class. So this is the base class. So this class is the base class for the saver. It specifies the signature of all method used in the implement the save sequence or business object provider. So this is how the architecture look like. If you want to see these classes, we can see here. If you click on the CL ABAP behavior, for the in our case it is a handler class. If you open it up, this is in turn inherit, as I told you, from the CL ABAP behave. This is the supermost class. In this class we will be having global declarations, some of the constant and some of the method for the messages, and this in turn will called here. And in this class also we don't have much method, but whenever we create the local handler class, we have to inherit this particular class. In this case it got automatically generated, no need to worry. But sometime we want to create another local handler class just below that, then we have to make sure we have to follow the same thing. If you don't inherit from here, it will not work. The third thing, so a handler class defined, whatever we are defining in the local types, those will be already will go in this particular include code CCIMP include. As you know already, I know from the ABAP, each global class, for example this class, have it will save the data in the includes. If you do Control Shift A, Control V, and if you do equal to, then there are multiple includes are there. So in this case, the CCDEF, this is the include is there, where this all the local classes and the method local classes implementation will be saved in this particular include. So that is the only this statement is saying. And for modularization purpose, one behavior pool can define several handler classes. As I told you, in our scenario also, what we will do, not what we will do, I will do now itself. So instead of defining the one class, what I will do, I will implement the several separate class. For this I implemented for the travel. In the same way, I will create one more class for the booking, one more class for the booking supplement. Implement in class booking supplement. Control Z. So in this case, I will give same name as SUPPL, booking supplement. Control F3. Now let me define, just you can click Control 1 and define this create behavior implementation for this particular class. Next and finish. So you can see this class also created, and it have its own local types. If you see global class, and this global class basically for the, if you see again, this is abstract final, and again for the travel taken. And if you see the local types, as of now there is no local types. So since we didn't define any method, that is the reason local type is blank. So let it be. So let me Control F3 activate this as well. Okay, same way let me create for the booking supplement also this particular class. Control 1, create behavior implementation, and click on next button and click on finish button. So why I have created 3 class? I don't want to mingle up all the things in one class. The travel related implementation I will do in one class, booking related I will do in one class, and booking supplement related implementation I will do in the one class. So this is also we have created. Control F3. As of now I don't have any method. In upcoming videos we will create the method and we will understand each and everything regarding those methods. So that is the reason I am telling, for modularization purpose we can create multiple behavior pools. In this case I have created 3 behavior pool. Apart from this behavior pool also you can create the auxiliary classes as well. The one class in SE24 you can create, and some common method which you are using in the different behavior pools that you can create there, and those method you can call there for the modularization purpose. This is the good techniques to do to create one auxiliary class also. That also we will create in upcoming videos, and some of the common things which we are using in our different entities that we will declare there, and we will call that auxiliary class in our this behavior pool classes. So like that it is there. So like our main class, all the classes, handler classes, are abstract and final, and since we can't since instantiating and calling only happens through the RAP runtime, we can't instantiate and call this particular classes. It will automatically happen through the RAP runtime environment. At the runtime engine, the RAP runtime engine, it will call automatically these particular classes. So the handler method, so these are all about the handler class. And now inside this class, like we have implemented one global authorization in our scenario. If you see in this method, let me open this up, z travel takem and local types. I have created get instance authorization. We can create we have to give the method, then method name, and this is the important for what purpose you are creating this particular method. In this case I'm creating for instance authorization. There can be different purpose. You can see your purpose can be global authorization, you want to create for log purpose, your modify, numbering, pre-check, read, validation on save. There are different purposes are there, so that we have to specify. Then we have to specify importing parameter. Then there are something called the request. Whatever the result we are gonna get, that we will be getting here, and for this particular behavior definition and whatever the request authorization, what kind of authorization you want, that will be here, and for which entity you want, this will be here. In this case this travel entity, and result we will give in this particular table. We will discuss about these all the things, don't worry. So this I just want to give how we declare the method. So apart from this particular, so we have to define method, then method name for which operation, and we have to specify the importing, exporting parameter. Importing, then again we have to specify for what purpose you want to importing, and apart from the importing parameter we have the changing parameter. So at least one importing parameter is mandatory, you have to make sure. In the changing parameter you can have these 3 mainly changing parameter are there: failed, reported and mapped. We'll discuss more about this one just to give overview. So one more important thing, so for modify, in our case, like for authorization we have given, or for instance authorization, in same way we can give for modify, or for create also we can give. These are the RAP specific statements. So there is one thing is called this, all the data, the importing, exporting parameter, all will be typed with the data type that is called the derived data type. This is the most important concept in the BDF. To understand the derived, like we have the normal type, we use the type, then data element name or the table name or structure name. In the same way in the RAP we have something called the derived data type. We will discuss in upcoming slide what is this derived data types, but we have to make sure that all the parameter, almost all the parameter will be the derived data type. So each handler method must have at least one importing parameter. As I told you, there should be at least one importing parameter, and we can have this changing parameter. So for the mapping information we have the map parameter. For the failures we have to fill in the failed, and if we have some error message, we have to fill in the reported. So this we will do all the things when we do the implementation, just to understand what all are the structure of our class and method. So those we are understanding here. Before going further, I just did some given wrong information. So what I told you, let me do control. What I told you, we created the different local handler classes. No, we didn't create the different local handler classes. Instead of, we have created the different behavior pool for each entity. You can create the different local handler classes also for each entity, but in this case I have created the different local behavior pool itself. Means in this case, the global behavior pool itself for each entity. Why I have done this one? If you create the local handler class for each entity, suppose in future some changes come in one entity, then we are touching the old code of this particular behavior definition. So instead of the, for example, we have some changes in the travel entity, we don't want to touch the booking and booking supplement, then even you are making changes in the travel entity, since we have wrote the same code, since there is the different local handler classes are there for relevant to booking and booking supplement, that also will be captured because these are the local classes. So in this case we have created the behavior pool, global behavior pool, so it will be not touched. You can create as many as behavior pool as per your requirement. So this is one thing. And you can create, if the application is smaller, then you can create local for each entity local handler class also you can create based on your requirement, and that we will do usually. The derived type are the special kind of the types in ABAP, or we can say behavior definition language. Like in the normal ABAP we have the types to declare the tables and the work areas or the class. So we have different types we use. In the same way in the RAP we have different kind of type, that is the derived type. So name itself so this derived type is the derived by the ABAP runtime framework. So based on your CDS entities and your behavior definition language, it will be automatically derived by the ABAP runtime environment. That is the reason we call them derived type. So what is this actually, this derived type? So derived type will have the information related to your CDS entity, along with there will be some additional parameters. For example, we are doing some operation. For example, we are doing the create, update and modify. These operation when we are doing, then we are interacting with the so we are calling basically one method. So when we are calling one method, we have to pass some information, and then we have to get some information from that particular business object. Suppose I want to create this data based on the, or suppose I want to update based on these key fields, and this description I want to update. This information I have to give to the business object, and business object also reply me, I have updated successfully, and this information is updated successfully. So to give the information from there is two terms are RAP BO consumer and the RAP BO provider. The consumer give the information to the BO provider, business object provider or business object we can say. When he give the information, the type of those methods, for example importing and exporting or changing parameters are there, those types will be the derived type. So those derived type not only the having the information of the CDS entities or the structure of the CDS entity, plus some additional thing will be there that is relevant to that operations. For example, I want to do create. So apart from that, the data which we want to create, those data I will be needing some additional information to create the data in my system. Those additional information will be given in the, apart from the CDS entity type, those additional information. For example, if I am this particular creation is relevant to draft or not, you are using the early numbering or late numbering, those kind of information also I want to give when I want to create actually the business object or data in the system. So those additional information, or if I would have used a normal type of this particular CDS entities, then I would not able to give the additional information. To give these additional informations, SAP come up with this derived type, where we can not only pass the CDS entity type, apart from that we will pass some extra information to the business object. So based on that extra information, that particular business object perform those operations on those particular tables on CDS entities. So that is the reason I told you here as well, the behavior derived type contains not only the CDS entities but the RAP component give the additional information. Those additional, how we will get to know these are the additional information? Wherever you will see in front of the component percentage symbol, those are the additional component which is giving us the additional information. We will see when we do the coding in depth, but we have to understand first what is actually this derived type. The last thing, the parameter rep, all the parameter of the rep business object, most of all the parameters are the derived type. Whenever we declare the methods, we have the importing parameter, we have the changing parameter, those all parameter will be the type of derived type only, not normal type we not use. Derived type will be there where we'll be having those particular entity information along with the some additional information. Those using some of the fields, those fields will be having in front of percentage, and the something called those field also will be grouped under the field group. We will see those all the things when we do coding in the system. So these are the basic things we have to know whenever we are doing coding. So that is the reason before going to the in-depth coding, we have to understand this simple what is derived type, what all are the different kind of classes. Those we will not understand and simply will go coding, then all things go above head, or simply we are writing for create update, but we will not understand how it is happening and which parameter we have to update, which additional percentage parameter, what time we have to update, what is CID, what is PID, what is transactional key, what is these all the informations are, these all are the additional information which we will get through this derived type. So this is the very important thing for us. Again, how to declare this derived type? Anyway, normally how we will create the internal table, I type this type of this particular internal, this database table. Same way we have to type table. In this case, instead of giving the table name, we have to give for which operation you want to create, because the derived type always linked to the particular operation and for which entity you want to create. The derived type always need two information. One is the CDS entity information and second is which operation you want to do. First operation, based on the operation, those additional parameter will be added in that particular derived type by the ABAP runtime environment. So that is the reason whenever we create any derived type, that time we will give for which operation you want to create and on which entity you want to create. So apart from using this particular syntax, we can use one particular class. There also we have to pass the same information for which entity and what is the operation. It will create the automatically derived type for us. And this syntax also we will use to create the data object for the derived type. So we will create and create data object reference type of derived type we will give here. In this derived type information, what information we will give? What is the business definition for that you want to create the derived type, what is the entity you want to create the derived type, and what is the operation you want to perform. So you have to create this LO_travel type of this particular, my business travel definition is the travel, this GI_travel, my entity is GI_travel, and I want to do the create operation, so type equal to C. So in this case, create this kind of data using this, I will create the data in the system. So those we will learn when we will learn when we do real coding. It's a lot of things are there, a lot of for the each operation, lot of other additional parameter for which operation, what parameters will be added, those will be there. But to understand initially, we should understand what is actually the derived type. So some of the example over here, so you can see I created this particular derived type created for the create operation on this particular entity, and this particular derived type again create for the create operation only, but create with association. We have the child entity, we want to not only want to create read, but we want to create the parent, we want to create the child as well. For the update also we have to we are updating the operation on which entity we want to do. Okay, so in the same way, these are the types and these are the data variables are there, and here we have the data objects. In the data objects, I hope so you know what is the difference between the types and data objects. It's the same class, and we have the class and class objects. Same way we have the types and data objects. So in the we want to create the data object, the one way we can, as I told you, we can use the directly class, just we have to give the entity name and the what operation you want to perform, or we can use this particular syntax create data reference, where we have to pass the definition language, behavior definition name, the entity name, and what is the operation you want to perform. Those all things we will see in detail in upcoming video when we do the coding, but just to understand what is the derived type, just I have explained here. I think in this video lot of theory was there, but theory is always needed before doing the practical, otherwise we'll not understand a lot of practical things. So before going to next video, please like this video, share these videos with others as well. With that, thank you and happy learning.